Now, flat earthers love to present observations which they claim debunk the globe, usually involving viewing objects way off beyond the horizon, and they argue those objects should not be visible as much as they are on a globe based on their maths. Normally because they've missed out some variables such as observer height and or refraction.
How to stop compulsive lying. Do you find yourself lying compulsively? Pursuing treatment for mythomania or pathological lying can help you stop this destructive behavior. You will need awareness of your problem, a trained mental health professional, and determination. Optional, a journal, and prescription medication. Step 1. Come to terms with your compulsive lying.
Normally because they've missed out some variables such as observer height and or refraction.
Observer height is almost always included by people presenting flat Earth evidence, Dave. It's funny you mention this, because in the TV series Genius by Stephen Hawking, the globe propagandists are the ones who failed to include observer height in a laser test over a lake. There were several other issues with the series too, but it's no wonder why PBS removed the video of that laser test from the internet after being exposed by others. We will cover the various issues of Earth curve calculators that use standard refraction settings later. But let's see how the mainstream lies and what happens when flat earthers accurately account for the variables.
Here's how we know that they are frauding the whole system, because all they did was make their results match what they thought they should be. They used the curvature calculator, which for 3 miles equals 6 feet. However, they forgot to put in the eye height of the observer. If they would have done that and put in the 2 feet high laser pointer and then put a target distance of 3 miles, well, sorry. The target hidden height should have only been 1 foot, not 6. That's called science fraud, my friends.
Okay, so they measured the heights of the laser pointer. Here are a few pictures so you can see how they did it. Okay, now they are trying to put the laser beam as parallel as possible to the water surface with the scanner in the laser units.
A legjobb, hogy így szembe vagytok. Tökéletes.
Alright, now here is the boat moving away from them. It's moving as slowly as possible so as not to lose the laser beam from their sides. Well, when they reached this point, which was about 3 kilometers away, they kinda lost the beam and suddenly another boat passed by and it appeared on it.
Ott a hajón, másik hajón!
Let me speed up this video a little bit. Well, as you can see, the laser beam remains at the same altitude and our guys are trying to reach the end of the laser beam, which is gonna be 5 kilometers or 3.10 miles approximately. As you can see, the laser beam is still at the same altitude, 1.6 feet above water surface. Now they are 3.10 miles away from the shore. It got dark, but darkness makes the laser beam more visible. They didn't want to go farther than that because that was almost the end of the beam. The laser was still at 1.6 feet above water surface. You can see the divergence of the laser beam, which was 1 meter in diameter. The bottom of the laser beam started to hit the water surface.
How do you measure a flatness of a lake?
With a huge ruler.
She has a point though, you need something that you know is flat to measure the surface of the water against.
Yeah. 2 feet, 7 inches.
First is...
What is that? The laser is not even parallel to the water surface.
A powerful laser, which projects a straight beam of light across the surface of the lake. Next, they'll need a boat. If the lake is flat, the laser beam and the water will always be parallel to each other. Seen from a boat, the beam would always stay at the same height above the water, no matter how far you travel into the lake. But does that happen? And can the team work out why? Time to find out. The boat has a whiteboard attached to it, which will be a target.
We're looking for the laser beams so that we can mark it on the whiteboard.
Oh, it's sitting off that. And we made the first measurement, and I was pretty confident that we weren't going to find anything.
A little more to the right.
Almost there. Here we go.
They take their first reading 500 feet from the shore.
Okay, what was the height of it? Got it.
For the next measurement, they'll need to go much further out.
Okay, so now I need to go 3 miles away from the laser.
Alright.
Awesome.
Remember, if the lake is flat, it would be the same height as before.
I don't even think this beam is going to hit our boat. We're going to have to measure it on something else. Alright.
We made the second measurement, and my whole world fell apart. It's like 6 feet.
Yeah.
Yeah.
It seems a lot higher.
Okay.
You got it?
Huh?
Alright.
Just 3 miles away, the laser seems to have risen by 6 feet.
So his boat was almost at the same distance as our boat, 3 miles away, which is almost 5 kilometers. And his laser pointer was at 2.7 feet, but our laser was even lower than that. It was at 1.6 feet, and he claimed that the curvature was 6 feet in 3 miles. Well, guess what, Mr. Steven? You are a liar. But I'm gonna let our man tell you this.
Look, Mr. Stephen Hoaxking, I knew you were lying, but I didn't have the definite proof to prove you wrong. But your deception made me repeat this experiment to discard your so-called evidence. We got a boat at 5 kilometers or 3.1 miles away from the laser pointer, and the laser beam was exactly at 50 centimeters, which is 1.6 feet above the water surface, and we didn't notice or experience any curvature drop at all. You are nothing but a liar, and your cheap actors didn't do a good job either. We have just discarded your so-called scientific evidence. Game over.
Thanks, homie.
Normally because they've missed out some variables such as observer height and or refraction.
The 12-kilometer distance calculation based upon the WGS-84 model results in a target hidden height of 4.56 meters or 14.96 feet. The lake temperature was 2 degrees Celsius and the air temperature above the lake was 3 degrees Celsius. The ambient conditions showed the refractive indexes were about the same at the two sides of the lake where the teams were positioned. The difference in temperature was marginal both vertically and between the two sides of the measurement. The difference in humidity and temperature between the height of the laser and the height of the camera was insignificant. FE Core concluded that the gradients above the lake did not cause any significant refraction of the laser beam. To reach the maximum precision, FE Core factored in all the possible corrections for the WGS-84 geoid and calculated the mean sea level ellipsoid, the geoid undulation, and the refraction corrections for each measurement. The height of the laser pointer was 1.5 meters and the observation position height was at 1.6 meters. The WGS-84 geoid map shows 0.129 meters geoid undulation at both sides of the measurement. That meant there is no significant difference in geoid undulation. The TLT measurement data shows that at least 2.96 meters of curvature was missing on the total distance of 12 kilometers on the surface of Lake Balaton. There is also a possibility of a local geopotential anomaly, but the WGS undulation map clearly shows that this was not the case.
Normally because they've missed out some variables such as observer height and or refraction.
The blue laser was placed at 2.2 meters above the lake surface. By calculating the target hidden height from a distance of 12 kilometers, we get the 3.52 meter minimal observation height to be able to see the ray of the laser beam. The measurement clearly showed that the beam was visible from 1.6 meters above the lake's surface. The ambient conditions at the time of the measurement indicated a marginal refraction of the beam based on the difference of the refractive index on the two sides. Our calculation gave a result of 0.235 millimeter deviation from a perfectly straight line at the time of the measurement.
The corrections have been calculated for the mean sea level, ellipsoid and geoid undulation. Their magnitude is also well within the margin of error.
Normally because they've missed out some variables such as observer height and or refraction.
Before any targeting with the laser can occur, the salad needs to be properly set up and calibrated. This process involves careful leveling of all parts of the device and laser. To do this, the salad is put down on a platform and each of the 4 legs must be adjusted individually to make sure all beams are level. After the device is leveled, the laser beam must also be leveled. This is done in conjunction with a laser level device, which is placed directly behind the laser. The difference in height of the laser level and the laser itself can now be adjusted to be the same across the maximum distance available at that location. Then the setup is ready to start with our newly developed GPS-based terrestrial laser targeting procedure.
Normally because they've missed out some variables such as observer height and or refraction.
On April 8, 2018 at 1 o'clock a.m., the blue laser was on the salad at 2.85 meters or 9.35 feet above the lake's surface. It was seen at the target 1 position, 21.26 kilometers or 13.21 miles, at a height of 1.2 meters or 3.94 feet above the lake's surface. It took less than 60 seconds for them to see the source of the laser at the target 1 location.
Can you guys see it?
Yeah, I see it. Yeah, it's there. Okay, yeah, we can see it really well there.
Can you see the reflection on the water?
I'm gonna zoom out.
Yes, we do. Yes, we do. Look at that. Wow. Oh, man, that is irrefutable.
Yeah.
Awesome.
I can watch this all day, you know.
This is awesome.
Yeah, this is really awesome.
Look at that reflection. That reflection absolutely caps it.
Yeah.
Yeah. That caps it. That annihilates any possibility of it being refracted, and that also annihilates any possibility of any convexity.
Yeah.
I mean, you cannot track it with being curved.
The 21.26 kilometer calculations based upon the WGS-84 geoid model resulted in a target hidden height for measurement 3 Isle Lake, target 1 location of 18.18 meters or 59.6 feet. The camera height was 1.2 meters. The WGS-84 geoid model differed by 16.98 meters in this measurement, which meant 93% of the target hidden height was visible. The lake temperature was 7.6 degrees Celsius or 45.7 degrees Fahrenheit, and the air temperature was 10.8 degrees Celsius or 46.4 degrees Fahrenheit above the lake. The ambient conditions showed the refractive indexes were about the same on both sides of the lake. TLT calculations factor in any variations in recorded data and geoid datum parameters of the WGS-84 mathematical construct. Both target and laser positions are at 0 meters mean sea level. The WGS-84 geoid undulation map shows a marginal 23 centimeters or 9 inches height difference at the 2 positions.
Normally because they...
On April 8, 2018 at 3 o'clock a.m., the blue laser on the salad was 2.85 meters or 9.35 feet above the lake's surface. It was seen at the target 2 position 28.68 kilometers or 17.82 miles away at a height of 0.85 meters or 2.79 feet above the lake's surface.
Okay, check this out, brothers and sisters. 28 kilometers in your face.
Wow. Wow. Awesome. That is awesome.
My camera is 85 centimeters above sea level.
Look at that. That's amazing. You can see it reflecting off the lake water.
Yeah.
That's astounding.
That's the nail in the coffin.
Yes, it is.
Oh, this is so great, boss. It's really awesome.
The 28.68 kilometer calculations based upon the WGS-84 geoid model resulted in a target hidden height for measurement 4 ISIL Lake target 2 location of 40.21 meters or 131.9 feet. The WGS-84 mathematical construct differed by 39.36 meters in this measurement, which meant 98% of the target hidden height was visible.
Normally because they've missed out some variables such as observer height and or refraction.
On April 22, 2018 at 12 o'clock a.m., the blue laser was on the salad at 2.92 meters or 9.58 feet above the lake surface. It was seen at the target 3 position 18.73 kilometers or 11.64 miles away at a height of 1.6 meters or 5.25 feet above the lake surface. The 18.73 kilometer calculation based upon the WGS-84 geoid model results in a target hidden height for measurement 5 ISIL Lake target 3 location of 12.504 meters or 41.024 feet. For measurement 5, the WGS-84 mathematical construct differed by 10.904 meters, which meant 85% of the target hidden height was visible. FE Core examined the effects of refraction through the gradients in the air by adjusting the beam vertically. It was concluded that with the present ambient conditions at measurement 5, the beam was refracted downward by a maximum of 1/100th of a millimeter.
Normally because they've missed out some variables such as observer height and or refraction.
Yeah, but the intensity is going down.
Yeah, it's going way down.
Okay, just put it one step up, stand up. Okay, one more. Put the steps.
Wow!
Put the steps on.
I think I just caught that.
Put the steps.
Wow!
Put the steps on.
I think I just caught that.
250,000. One more. One more. Okay. Yeah, one more. That's
Maybe
it,
one
bro.
more. Maybe. Oh,
Yeah,
I can
one
see
more.
it.
One more.
One more.
You got it?
I could tell I was looking right at the beam. Or down.
Down?
Yep.
It's going up.
Okay, what now? This one's up.
I think we're looking at it. Right, not right.
Yeah.
With the naked eye.
FE Core examined the effects of refraction through the gradients in the air by adjusting the beam vertically. It was concluded that with the present ambient conditions at measurement 6, the beam was refracted downward by a maximum of 0.064 millimeters.
We were shooting the laser 40 kilometers across the lake. We did find it on the target location, but it was already getting light, so the intensity of the beam was almost not visible anymore. And we had some issues with finding the right orientation of the beam itself. So now that we know where to actually point it, we're going to try it again today to get it on tape.
Measurement 7. In the evening of April 22nd, the team returned to the Target 4 location. They worked late into the night taking many pictures. Rick's camera was set to take one picture every 5 seconds.
So the source of light, whatever's going on top of the water, you're not going to be able to see it. There's too much humidity, the water's blowing, it's spraying.
Yeah, and it's windy on your side, right?
Oh, it's real windy on our side.
Yeah.
Okay, buddy.
Patrick, can you see
All
it
right.
then?
So, there we go.
Nothing at all?
I cannot take it off camera. There's just not enough light coming off of it. First of all, there's too much light pollution coming at us too close. Then it'll knock that out.
Measurement 7, Lake ISIL Target 4. On April 22nd, 2018, at 11:20 p.m., the blue laser was on the salad at 2.92 meters or 9.58 feet above the lake's surface. It was seen at the target 4 position 40.14 kilometers or 24.94 miles away at a height of 1.5 meters or 4.92 feet above the lake's surface. The parameters and outcome of measurement 7 was the same as the one from the previous night. The only difference was the maximum refraction of 0.133 millimeters caused by the slightly different ambient conditions. The observers should not have seen the laser at any height below 89.3 meters or 293 feet, but the beam was recorded from a height of 1.5 meters or 4.92 feet.
Stop. Okay. Bring it down now. The laser down.
Going down.
Zach, if you want to record some of this, you can. I didn't know what you were doing. I'm trying to record something. Okay, you still coming down? Yep. Okay, stop. Go back up a little bit.
Conclusions.
The results of the 7 TLT measurements indicate that these two lakes do not conform with the WGS-84 mathematical construct and that they lack the predicted convexity. The testing results agree with the analysis of error sources. In summary, the testing results of the lake surfaces were plus or minus 0.2 meters and the relative accuracy was within 1%.
Normally because they've missed out some variables such as observer height and or refraction.
In conclusion, the TLT measurements met the accuracy of the experiment design requirements and provided a definite deliverable output.
The surfaces of Lake Balaton and Lake Isel do not conform with the predicted convex shape of the WGS-84 mathematical construct. Through analyzing error source models of TLT measurements and corrections for the geoid surfaces, we determined that the TLT measurement results conclusively prove our hypothesis of non-convex water surfaces.
Never in history have independent researchers been capable of falsifying these axioms by direct observation and measurement. FE Core has made new and meaningful discoveries with its very first project establishing an enormous amount of missing predicted convexity on both lakes. Thanks to the support of all FE Core subscribers and project participants, a great addition to the body of scientific knowledge has been made.
I think they think refraction is just some magic excuse to explain away things.
Nigga, please.
Hey. But one problem with a lot of the observations is they can be quite tricky for people to replicate for themselves.
If they're trying to figure out the shape of the Earth. There's finding a suitable location where you can view objects going beyond the horizon, plus there's needing to know all the variables that are at play, and then there's knowing the maths involved in figuring out what you should expect to see.
So today I want to present a much easier observation that pretty much anybody can make around sunrise or sunset that is easy to explain with the Earth being a globe, yet seemingly unfathomable if the Earth is flat. How the bottoms of aeroplanes can be lit by the sun. And for anyone who struggles with maths, this doesn't really require any. Although if you do struggle with maths, then you should check out today's sponsor, Brilliant.org. By name, by nature, it's a brilliant way to learn online.
It's so dumb. It's so dumb, it's brilliant. No! It's just dumb!
At the start of the year, I went across the pond to New York for a few days, and on one of the evenings, we went up to the top of the Rockefeller Center for sunset.
Ah! That's pretty interesting.
We got there about an hour before the official sunset time and stayed there taking photos of New York until long after the sun had disappeared from view. Now, on a globe, the sun disappears below our horizon because the Earth is rotating.
Quote mining, quote mining, quote mining, quote mining. quote mining.
Flat earthers argue that the sun is actually remaining at a constant altitude above a flat, stationary Earth, although they can't agree on what altitude the sun is.
When the sun is directly overhead, the refraction is near zero, but you still can't say where the sun actually is. As the sun travels towards the west, the atmosphere creates an image of it for every eye. So anyone who looks at the sun from the same angle as you, but from a different city, will see the apparent sun in a different position. But no one can see the sun in its real position. So if you try to triangulate the sun, you will never get the exact distance. This is like trying to triangulate a rainbow.
I just can't do it.
Many flat earthers have said it's around 3,000 miles, others have said it's much higher than that, but most of those aren't prepared to actually put a figure on it.
So if you try to triangulate the sun, you will never get the exact distance. This is like trying to triangulate a rainbow.
I just can't do it. I can't take this shit no more, man.
But the general consensus amongst seemingly a vast majority of flat earthers is that it is much higher than aeroplanes fly. And what we perceive to be sunset is actually just the sun moving away from us.
Most common answer to this question was simply perspective. While this does play a part in how day and night work on flat Earth, it's not the only thing at play. There are a few different things working together in harmony to create day and night on our plane. We have the midnight zone, where it is too dark to see even at high noon because the light can no longer go through the layers of water. The same thing is happening on our Earth's surface, but at a much larger scale. Clouds and water vapor obstruct the light of the sun and it can no longer illuminate your area. This is a clip from a video made by my good friends Zach and Steve. In this animation, Steve rendered the stars over flat Earth. The top is rendered with the atmoplane and the bottom is rendered without, showing how perspective alone does not explain how the luminaries appear to go below the horizon.
If you take a look at any animation of the flat Earth, the atmosphere is always missing. It's like drawing the flat Earth in a vacuum of space. And this is why the sun never sets on the flat Earth, because there is no refraction. Now my question is, have you ever seen an animation of the globe Earth model with the effect of the atmosphere? I'm not talking about just drawing the clouds or the air. It's not just drawing them. It's how to make them work as they do in real life. You know what I mean? They know how the refraction works and they know how the atmosphere works, but they never add it to their animation, you know. And if they do, the sun would never set as they claim it does. And we can prove that too.
Modern science claims that the apparent sun sets after the real sun because of the atmosphere and the effect of refraction. So when we see the apparent sun above the horizon line, that is just a reflection of the real sun, which is already set. But when we added the atmosphere to the globe model, it did the same thing that it did on the flat Earth model. The apparent sun goes down first, and the real sun follows it. That is contrary to the way refraction is normally presented.
They say when the bottom of the sun touches the horizon, its true altitude is negative. Did you see that? That means it shouldn't even be there.
That is contrary to the way refraction is normally presented.
And since they are assuming a curved Earth, imagine if they assumed a flat Earth. That would really change all of their calculations. It then talks about an example once of how the sun set only to rise again an hour later. That's right, an hour later. And then it set an hour after that. And then it rose and then set again within the next 20 minutes. This is a classic example of advanced sunrise and sunset.
Except whilst I was at the top of the Rockefeller, soon after the sun had set, so the sun itself was no longer visible, but the sky was still quite bright, I spotted about a half a dozen aeroplanes cruising in the sky between myself and where the sun had just set, and they were glistening with sunlight bouncing off them. Now, in this photo that I took, this antenna in view is the top of the H&M building.
I have to ask you, Dave, did you also notice the sunlight shrinking to a central point across the length of the horizon? This observation alone debunks the globe.
Light following the sun over the horizon, and it shrinks as it goes over. Now, there's no way it would do that if the sun is 93 million miles away. Okay, first I'm going to show you some footage from the ISS. Okay, now watch this animation. Watch this sunset. Now this is exactly, if they came to me and said, do an animation, this is how I would do it. If the sun were 93 million miles away. Just like that. Have the whole horizon fade evenly. But that's not what we see. Okay, these next 3 slides, the sun is almost set already behind the horizon, but watch as the sunlight shrinks and follows the sun. It's definitely a locally illuminating sun, not far away, not very big, and definitely not 93 million miles away. Okay, remember this video from the beginning of the video? I showed you this one and how it's circling over the earth, and watch it sweep to the right like a bowler bowling it in there for a strike. Okay, now I want you to pay attention to the way the light follows the sun. The sunlight's going to shrink, right, as it follows the locally illuminating sun. Now watch this. See it shrinking, following the sun? You do not get that if the sun is 93 million miles away. The entire horizon should fade evenly, just like this supposed shot taken from space of the Earth. You can clearly see the way they depict it. They depict the demarcation between day and night, or light and dark, as a long straight line. And you can see the long straight line moving as one solid piece. That means that the sunset should all fade, the entire horizon should fade evenly. But that's not what we observe, as we will see and as we've seen in the footage so far. The sunlight shrinks and follows the sun over the horizon.
So I had a look at Flight Radar 24, and at the time that the photo was taken, there were several planes in that direction cruising just north of Baltimore, which would put them in the region of about 225 kilometers or 140 miles away. Some obviously a bit further, some a bit closer, but they were in the general vicinity of southern Pennsylvania. And the key question is, how is the light reflecting off a plane between myself and the sun that would allow me to see a reflection of the sun? High school physics covers the law of reflection, which is angle of incidence equals angle of reflection, i.e. if you shine a light at a mirror, whatever angle the light is approaching the mirror at is the angle that it will be reflected away at.
So the mirror is flat, and they're reflected like that, perfectly reflected. All of them are the same. In diffuse reflection, it is by no means the same. The reflection is erratic. So you'd have this ray coming in this way, and it would be reflected upwards, and this one would be reflected sideways, and all the rays are moving in different directions because the surface is rough. It's not straight, it's not flat, nothing is reflected in the same direction.
So, given that the plane is much higher than me, and I'm seeing the sunlight reflecting off the underside of it, then the reflected light from the plane must be travelling downwards to reach me, meaning the incoming sunlight that's heading towards the plane must therefore be travelling upwards.
Before getting into all the different reasons and details of how planes are lit up from their bottoms, let's first get into how light refracts upwards on a flat Earth by reading a message from Dr. John D. to Mick West concerning this. This information will also show how the globe's excuse for refracting lasers around its curvature and how so-called standard refraction for Earth curve calculators are absolutely absurd contrivances. There will be no voiceover, so if you want to learn, you must do some old-fashioned reading. It will be okay. Feel free to pause at each slide.
So I would be very interested to hear any explanations from flat earthers as to how this observation would be possible on a flat Earth.
Even without diffuse or specular reflection from the Earth, light will simply refract towards the airplane from the warmer, less dense air beneath it. It's no miracle of science or a huge puzzle to solve. As we've seen and will continue to see later, sunsets and shadows debunk the globe and can only prove the flat Earth.
I've heard one, because I posed this observation to flat earther Gary Wybenga during a stream on STST's channel.
The plane is tilted slightly up because that's how they fly, right? Over the plane of the Earth, they have just a slight tilt up, which means you're going to get a slight angle to the bottom of the plane.
I will admit that response almost broke me.
I've already broken you, Dave. No need to worry about that anymore.
Now, commonly, yes, planes do indeed fly slightly nose up. Slightly. They don't fly perfectly level because at high cruising altitudes the air is very thin. So to generate sufficient lift to maintain their altitude, they often fly with a slightly raised angle of attack on the wings. But we're talking about 1 degree here.
Actually, it's 2 to 3 degrees. That isn't the cause for light hitting the bottom of the plane, but it is a variable, Dave, and just another example of you being wrong and trying to downplay things.
However, even that wouldn't actually explain the observation because you can't get light to shine off the underside of an object when the object is that close to level and the light is higher than it.
I stuck my foot in my mouth, and I'd like to think that I have the disease called foot-in-mouth disease because it happens all the time.
And the light is higher than it.
And I was thinking, okay, so let's just say the bottom of this little stand here represents the bottom of the clouds. And so as you can see here, the light is way above, it's well above what would be the bottom of the clouds in this example.
I would like to make a distinction here between clouds and solid metal objects such as airplanes. The reason that some clouds at times appear to be lit up from the bottom has more to do with the opacity of the clouds. Clouds absorb much more light, and planes do more reflecting and bending of light. Rob Skiba's demonstration here is better compared to airplanes than clouds, but is still absolutely valid. Let's understand the lighting of clouds at sunset first.
Sun rising, thick, opaque clouds. The tops of the clouds are clearly brightly lit when you can zoom in on them and take a look. Same thing here. The sun is always above the clouds. You can see the edges, no problem, right? You can see that the tops of these clouds are lit. The bottoms are not because the sun is above the clouds. Sun's coming into view. The tops of the clouds are lit. The bottoms are not lit. According to you, the bottoms should be lit. The sun is below this cloud, opaque. But look, this cloud right here is thin and translucent. So the sun goes through and lights up the whole thing. Let's look at another one. Here's a little combination of both. These clouds are thick and luminous. The sun is underneath. They should be lit according to you, but only the ones that are transparent appear to be lit. The tops are lit. Now, if you are unwilling to see this, you're a deceiver, whether you know it or not.
Time at the top left says 6:22. Sunrise, Saturday 9th of March 2024. In Coffs Harbour, 6:44. Come on, what are you doing? Camera. As you can see, there's the moon. So the sun's over that way, it hasn't risen yet. We've got some clouds here. And that little white spot right there. at the back of the cloud. Fading away a bit. Battery. That should be shaded. The sun will be below that cloud. Should be no white there. Look, oh, stop doing that. Look. You should have used an Android. Globaloid.
And the light is higher than it.
So let's see what happens. I turned off the lights and set my iPhone to record, and I'm showing myself here recording all of this with another camera, and I pulled the light back on the table, and watch what happens here. Ooh, check it out. And there's that refraction taking place again. It's got the light. It made the sun set, first of all, below the horizon in this case. And let's just show, this is just the iPhone view. I'm going to bring the cloud in here, and the platform represents the bottom of the clouds. So the sun's going down, and oop, there it is. The bottom of the clouds illuminated by a light source that's well above the clouds, moving parallel over a flat surface. So apparently it's possible for the sun to illuminate the bottom of the clouds even on the flat Earth model.
Here's a little combination of both. These clouds are thick and luminous. The sun is underneath. They should be lit according to you, but only the ones that are transparent appear to be lit.
Easy test if you want to try this out. Find a faraway light source like a street light off in the distance. Lie yourself down on the ground, take your phone and place it face down on the ground in front of you, between you and the light source. Then keep the phone parallel to the ground, so it's still facing down, but begin rising it up, and you will not see a direct reflection of that faraway light in your phone's screen. You will only see light that is traveling upwards towards the screen, and the light source would therefore have to be physically lower than the screen.
And I'd like to think that I have the disease called foot-in-mouth disease. Because it happens all the time.
Mitchell from Australia, and I'm going to demonstrate how seeing sunlight underneath clouds does not require us to live on a globe. Now this is a video that I recently took of a local street. As you can see, the further away streetlights get, they appear to drop to eye level and even below it. Please note, to the right there is a roundabout, and straight ahead there's a pole with two lights either side. I'm going to be using this as reference to measure how far away that last street light is. There are 8 street lights past that pole. For this experiment, I've used a tripod with a mirror attached to the top and a level on top of the mirror to prove that the mirror is level. Now this is just to show that it is a reflective surface, a mirror underneath here. Now this tripod has the mirror only 1 meter off the ground, well below the level of all of these street lights. So how is it that this mirror facing downwards can see the reflection of street lights well above the level and height of this mirror?
It's because the edge of the mirror is curving the light. The same effect will also occur on the curved metal surfaces of an airplane, even when perfectly level. Remember also that upward refraction from warmer, less dense air below is prevalent, along with any natural or man-made surface reflections from the ground. Again, none of this should be a surprise, Dave, or so easily excused away.
Plus, if it were because the plane is flying nose up, we should only ever see the reflection of the sun when the plane is flying away from us, because then pitching the nose up would be bringing the underside of the plane towards the sun.
Again, it's not tilt dependent at all.
The only way I could hypothetically see it happening at all on a flat Earth would involve an insane amount of upwards refraction. Insane amount of
Nothing out of the ordinary, everyday refraction, Dave. Let's hear your misunderstandings and strawmans now.
When I was viewing those planes in New York, they were in the region of 225 kilometers or 140 miles away from me. They were cruising around 35,000 feet or 10,600 meters. Now, based on time and date sun-moon map, at the moment I took that photo, the ground position of the sun was around the Cook Islands in the South Pacific, about 11,260 kilometers or 7,000 miles away from me. Now, as I mentioned earlier, flat earthers can't unanimously agree on what height the sun is.
So if you try to triangulate the sun, you will never get the exact distance. This is like trying to triangulate a rainbow.
I just can't do it.
However, I have had quite a few people give me the figure of about 3,000 miles, which is 4,828 kilometers above flat Earth. Now, from my vantage point, given the height of the plane and the distance that it is away from me, presuming the Earth is flat here for a moment, that would put the plane almost 2.7 degrees in the sky above horizontal from my location. So the light reflecting off the underside of the plane is traveling downwards at 2.7 degrees, meaning the light from the sun to the plane would have to be traveling upwards at 2.7 degrees. With the plane's altitude at 10.6 kilometers and the sun's altitude at 4,828 kilometers, that puts the sun 4,817 kilometers higher than the plane. From my location, the plane is 225 kilometers away and the sun is 11,260 kilometers away, so the sun is about 11,035 kilometers further away from the plane, which would put the sun 23.5 degrees above the plane. So for the light to get from the sun to the underside of the plane, it would need to refract upwards. So the incoming light would need to bend by 23.5 degrees just to get to level. It would then need to bend by a further 2.7 degrees upwards to get to the bottom of the plane, which is a total of 26.2 degrees of upwards refraction needed for the sunlight to get to the bottom of the plane on flat Earth in this instance.
The issue you keep having, Dave, is that you completely omit perspective with all your 2D orthographic side views. Like with streetlights, they are well above your head when directly under them, but far enough away, and you'll be looking straight ahead at them. Thus, some of its light is coming straight at you. So why, in this example, would you use a light ray coming in at that angle? Why not an angle like this? Or this? The refraction isn't an insane amount then, now is it? Even though we can see insane upward refraction at times too.
Which forced the beam to collide with an air layer at such an angle above the water at 5,000 feet or 1,500 meters distance away, it reflected part of the beam upward.
Do you realize that you're using sharp angles in your example when the refraction would be more of a gradual slope instead? Not to mention any light scattering too.
But flat earthers cannot really use that explanation, given how they dismiss atmospheric refraction when it's used to explain observations on a globe.
Nigga, please.
And globe refraction is nowhere near as severe as 26 degrees across 11,000 kilometers.
Again, Dave, it can only be a few degrees, and there is no way for you to determine, in real life, at what exact distance and location light started to refract anyways, and at what rate. We are also still focusing on only one variable here. Your globe refraction scenarios are completely absurd as well, as I've shown you multiple times through multiple videos. You're getting nowhere with this, as usual.
That is also then presuming that after we've had this huge amount of upwards refraction to get the light to bend round to the bottom of the plane in the first place, the upwards refraction would then magically stop once it's reflected off the plane to get to us.
Light is still traveling in all directions, Dave, diverging and scattering back out towards you from something miles away. Of course, light will still reach your eye, as well as go around you.
Really, the light that's coming off the plane should be also refracting upwards, meaning that for me to see the reflection, the light coming off the plane would have to be coming off steeper than 2.7 degrees and bending upwards to reach my eye.
So dumb, it's brilliant.
No! It's just dumb.
What is this, Dave? An ultra-mega laser beam reflection. No divergence or scattering allowed? This is so dumb. Do you only trick your audience with this nonsense, or are you convinced of this drivel as well?
Now, I know I said you don't need maths for this, and then I've just spewed a load of maths for refraction, but really, you don't need it, because it's not possible to get a direct reflection off the bottom of an object if the light source is higher than it.
It doesn't have to be direct, Dave.
And, oop, there it is.
But does the lowering of a light due to perspective make it direct?
Repeat the test, because science is all about observable, testable, repeatable observations, right? And this time, even though the previous test was done on a table with non-reflective tablecloth on it, I decided to take a piece of soundproofing that I had left over from when I was doing the audio drama for Seed the Series. And I even left the end curved up like this, so it really should prohibit any possibility of reflection bouncing off the table. But here we go again. Here's the same test, this time with soundproofing, lumpy soundproofing that would prevent any kind of reflection. And here we go. Oh, looky here. I got the exact same results. Huh.
Has the mirror only 1 meter off the ground, well below the level of all of these street lights. So how is it that this mirror facing downwards can see the reflection of street lights well above the level and height of this mirror?
In this video I took, the plane is flying across me, perpendicular to my line of sight to the sun. You can see the plane is initially dark because I'm looking at the shaded side of it, but then the underside of the front begins to glow. That is the sun's direct reflection, which then slowly moves towards the rear of the plane as it continues flying, and then within a few seconds it's moved right to the back and then disappeared. So the reflections only occur on the plane in a very narrow window relative to me and the sun.
Can light bend around corners? Yes, light can bend around corners. In fact, light always bends around corners to some extent. This is a basic property of light and all other waves. The amount of light that bends around a corner depends on the exact situation. For visible light on the human scale, the amount of light that bends around corners is often too small to notice unless you know how to look for it. The ability of light to bend around corners is also known as diffraction. There are two mechanisms that cause light to bend around corners. Number one, internal diffraction. Light is a lot more complex than many people realize. The ray picture of light, which describes light as a bunch of arrows traveling in straight lines and bouncing off objects, is an understandable and even useful picture, but it is greatly oversimplified. In reality, light is a quantized waving of the electromagnetic field. Light is always waving against itself, leading to internal interference of the different wave components in what we call internal diffraction. This diffraction causes a beam of light to slowly spread out as it travels, so that some of the lens away from the straight line motion of the main part of the wave. Even seemingly perfect laser beams spread out as they travel because of internal diffraction. This turning away of some of the light from the forward direction is a form of bending around corners, even when a corner may not exist. The tendency of beams to spread out via diffraction makes it so that a light beam can never be focused to a perfect point, and in consequence, light microscopes cannot perform infinite magnification. Many textbooks imply that all diffraction is caused by light interacting with an object. This is not strictly true. A finite beam of light traveling through free space where no objects are present will still spread out because of internal diffraction. Other names for simple internal diffraction are beam spreading or beam divergence. Note that when a system involves creating multiple beams, diffraction can lead to beautiful patterns of rings or stars, but the basic mechanism is still the same. Light interferes with itself. In general, a light beam spreads out more, turns the corner more, if the beam has a narrow beam width compared to its wavelength. Light can therefore be made to spread out more by reducing the beam width or by increasing the wavelength of the light. The wavelength of visible light is so small that you have to use very narrow beams of visible light in order to notice its diffraction. Such narrow beams are typically obtained by running light through a very narrow slit. For large wavelength light, such as radio waves, the bending of the wave around human-scale objects is much stronger. Note that the light from a flashlight spreads out not because of diffraction. It spreads out because the mirror in a flashlight is specifically designed to bounce light in different directions. Also, note that the fuzziness of shadows in everyday life is not caused by diffraction, but is instead caused by the fact that an extended light source creates many, slightly offset shadows of the object which blur together. Number 2. Interaction with objects. Light can also interact with objects in such a way that its ability to bend around corners is enhanced. Light passing through a simple slit and diffracting could be described as light interacting with an object, but such a situation is more a case of internal diffraction. The slit simply creates a narrow beam and then does nothing more, so that the diffraction in such a case results internally from a narrow beam interfering with itself. In contrast, there are cases where the interaction of light with an object does more to the light than just change its beam width. If light hits an object made out of conducting material, such as metal, the electromagnetic fields in the light exert a force on and accelerate the free charges in the conductor, thereby inducing electric currents in the surface of the conducting object. These oscillating electric currents create more light, and this light induces more currents. The end result is that part of the light that hits an electrically conductive material couples to the surface of the object and travels as a surface wave. Light can therefore bend around the corner of an object by riding the curved surface of the object. For a smooth surface, the light can travel along the surface for a relatively long distance. However, roughness, irregularities, cracks, bumps, and seams on the object's surface interrupt the coupling between light and the electric currents in the surface, so that the surface waves tends to scatter off into space at such obstacles instead of continuing to ride the surface. In optics, light waves riding the surface of a conductive object are called surface plasmons.
It's worth clarifying here, I'm not talking about seeing general light coming off the bottom of the plane during the day. There's always light reflecting off the plane. If there wasn't, we wouldn't be able to see them, which is what happens at nighttime. But during the day, that general light is just light that's reflecting off the Earth up to the plane. I am talking specifically about direct sunlight, which you can differentiate because it's much brighter, harsher, and it leaves a clearly defined shadow on the plane.
Which you can differentiate because it's much brighter, harsher, and it leaves a clearly defined shadow on the plane. You can differentiate because it's much brighter, harsher, and it leaves a clearly defined shadow on the plane.
Not the case, Dave. The light is way above here, and the light we see is still brighter, harsher, and there are clearly defined shadows. If I told you the light source here was under the lid, you and everyone else would believe it. But it's not.
Now, I can imagine some potential flat earther explanations. One might go down the road that the plane is cylindrical, so the light is shining against a curved surface. So, just in case, we'll address that one. Firstly, curved surfaces would not really change anything.
Do you find yourself lying compulsively? Pursuing treatment for mythomania or pathological lying can help you stop this destructive behavior.
Look at it bend and follow the length of the contours. These gentle sloping curves, like that on an airplane, are ideal for light to wrap around. Not to mention, airplane bodies are highly conductive as well.
For the light to approach from above and still continue downwards, the surface would need to be heavily angled so that the sunlight is almost just glancing off the plane.
What? Bro, what are you talking about, man?
Which you wouldn't get from the underside in level flight.
And oop, there it is.
Can see the reflection of street lights well above the level and height of this mirror.
But just to drive a final nail into this, like I said, this is a fairly easy observation to make. Not only have I personally captured numerous examples of this, but I happened upon a video from a channel called Xspot Aviation that does a lot of plane spotting videos. And one of theirs in particular I saw, I think absolutely destroys flat Earth. It's a video titled High Altitude Plane Spotting. It's numerous clips of planes all flying at high altitude, and it's done with a very impressive camera setup, because the views of the planes are extremely clear and the tracking is very smooth. And the video also includes all of the specifics for each flight as well, such as flight number, route, altitude, speed, etc. And there are two clips in particular that I would love to see flat earthers demonstrate. Both of them involving Emirates Airbus A380s flying between Dubai and London, both stated to be at 40,000 feet, and both captured at what looks more like sunset rather than sunrise. Both of them show exactly what I've been describing here, with the clear reflection of the sun gradually moving across the underside of the left wing. However, both of these also show some interesting characteristics. Firstly is the middle of the fuselage underside is clearly lit by direct sunlight.
It's important to also note that the sun might have set for an observer on the ground, but for the plane, it hasn't yet.
This area of the A380 is not a curved fuselage section like the rest of the plane, it's where the undercarriage goes and it has a flat bottom to it.
What?
No, Dave, it is curved and slopes. I don't know how you can't see that or claim that. The entire plane has curves in it.
So that tackles any potential claims about curved surfaces being the cause.
You serious?
Crucially though, is that not only do both videos show the undersides of the left wings being brightly lit, whilst the right wings are completely shaded, so the light is coming from the left side below the plane at a shallow angle, but we can also see clear shadows being cast on the underside of the wings. Those shadows are being cast by the engines, which are hanging below the wings. So the sunlight must be hitting the plane from below in order to be casting shadows of the engines upwards onto the underside of the wing. And to be casting clearly defined shadows like that must be direct from the light source. It can't be bouncing off the earth and reflecting up, because that would evenly light the whole underside of the plane. Explanation for flat Earth? I guess we'll have to wait and see.
Ooh, you just got schooled, son.
Like I said, that's it all easily explained on a globe.
They depict the demarcation between day and night, or light and dark, as a long straight line. And you can see the long straight line moving as one solid piece. That means that the sunset should all fade, the entire horizon should fade evenly. But that's not what we observe, as we will see and as we've seen in the footage so far.
That's it all easily explained on a globe.
This is not something that really needs to be explained most of the time. It's rather self-evident.
Well, actually, it's not self-evident, Bob. Not if you rigorously investigate possibilities of why or how this could be happening. And you know what's going on? The top of the mountain is actually above the clouds. So, and what we see there is a shadow cast from the top of the mountain. You see, it's impossible to cast a shadow on the underside of clouds when the object that's casting the shadow, the top of the mountain, is above those clouds. The only possibility is casting a shadow down on the clouds, and that's what I'm going to show you in this video. I'm going to prove to you that the sun is always higher than the peak of the mountains. And I'm going to show you that this shadow that you think is going up is not going up. It can't be going up. It's impossible for it to physically actually be angled up. It's only visually angling up. Okay, let's go. So I have these new photos, Bob, taken by mountain climbers on the top of the mountains at daybreak. Okay? And so I'm going to use what you just said, looking at this picture. Ready? Now, most people that would look at this photo would realize that in order for that mountain to cast that shadow downward onto the tops of the clouds at daybreak, the sun had to be coming from an angle or altitude higher than the peak of the mountain. This is not something that needs to be explained most of the times. Bob's arrogance right there and condescension. It's rather self-evident. Well, Bob, you're going to eat those words, right? Because you just debunked the spinning ball. Because all the shadows are down on top of the clouds, which means the sun has to be higher than the peak of the mountain in order to cast a shadow on the top of the clouds. Woo-hoo-hoo-hoo. Yes, my friends, Bobby. And this is daybreak. Excellent work, Bob. You just helped debunk the spinning ball Earth. All right, back to this picture for a second, Bob. Besides all the logical fallacies and presuppositions you just committed in your opening statement, there's another one that you did in there, and I covered these in my last video on you. And so here you are, Bob, jumping to an absolutely amateurish and wrong conclusion because you don't understand perspective. You're making an amateurish declaration, especially for a self-proclaimed science guy who should know enough to investigate more rigorously a visual phenomenon such as this, and not assume this or that or the other. You're assuming that the shadow is going upward. And you're assuming that for two reasons, Bob. One is because you believe the Earth is a spinning ball and that sunset and sunrise is caused by the rotation of the Earth and having the sun being physically lower than the mountain. The other is that you don't understand perspective, even though you claim to. Now, I know you guys make fun of it and call it flirspective, and the only reason you call it that is because you don't understand it. You've never learned it. You understand, right, that those clouds are not actually angled up and that the shadow needs to be cast on something. So the shadow is cast on the clouds. And so the clouds are parallel to the ground. They are not actually angled up. So what you're seeing is a perspective illusion. Okay, here's an example. I made this. This is CGI. I know you guys don't like CGI. You made a big deal out of that CGI image from my last video and said that, oh, why don't you represent it with a photo? Because you can. It won't look like that. Well, I got news for you. I'm going to go out and get that photo for you. It'll be in my next video, so stay tuned for that one. Anyway, so this is an orthographic view of a shadow, or side view. It's 2 miles high off the ground, 2 miles off the ground, and it's a mile wide, and it's cast on the clouds. And looking through this little window, this is what it would look like, right? Clouds are parallel to the ground. This shadow would go right across the screen like this, right across your vision, and would be parallel to the ground. Now, if you look at it head on, and it's coming towards you, okay, that's going to be on your eye line, right? And that's going to be your perspective view. It's going to look a lot different. Now, brace yourselves, because this is going to wreck your little claim that this shadow is going up. You are completely missing the boat, because you make fun of perspective and you don't understand perspective. You're going to be proven wrong right now, okay? Hold on to your seat. Here we go. 3, 2, 1, boom, bam, there it is. This is the same shadow as the orthographic view right here, but this is head on. And it's the same as this, Bob, your picture of Mount Rainier's shadow. Here's 2 miles off the ground. Here's 2 miles off the ground. Here's 2 miles off the ground, or 2 miles high. Here's a mile wide, what it looks like way back there at the horizon. Here's what a mile wide looks like here. Here's what a mile wide looks like here. It's climbing in the sky visually, but in reality, it's dead straight, flat, horizontal, parallel to the ground. Boom, boom, boom. And this proves that CGI that I did in the last video. This is how it appears to go up. Okay? Sorry to destroy your ball earth evidence. It's not. It's flat earth evidence. And notice that the shadow starts right below the peak of the mountain and at the top of the clouds. And that shows you that the peak of the mountain is up in the clouds. So the shadow is starting below the peak of the mountain. And it's staying parallel to the ground. It's not actually coming up, and it's not actually spreading out. It's just perspective, Bob. Okay, big mistake you guys make in your arrogance, right, and your quickness to make fun. You idiots miss the obvious. And what's obvious here is that the shadow cannot be going upwards because the shadow is on the clouds, and the clouds are not going upwards. The clouds are parallel to the ground. Okay, so I don't want to get too involved in this right now because I will cover this in my next video. I'll cover all the perspective of the shadows like that you see in and around and on these mountains. Okay? Okay, so this is a picture from the top of Mount Hood, and it's over 11,000 feet high. And at the crack of dawn, it's casting a shadow on top of the clouds. Okay, so what would that look like underneath? Well, let's go to the picture you put up. Or even better, let's see this picture that's more head-on so you can see the exact relationship. On the ground, from where you're standing, the person who took this picture, this is what you would see. So the sun is not casting its shadow upward to the underside of the clouds. It's casting a shadow on top of the clouds, which is also shading the bottom of the clouds. But now I know somebody's going to say, yeah, but look at the underside of the clouds are lit. That's another one you guys do. Well, it's reflection. It's primarily reflection, you know, because of the fact that you can see when you're standing by water like this, that reflection between you and the sun is only for you. Someone on the side cannot see that. See how the clouds get lit up just between you and the sun? That's unique to the observer. Right? Two people standing on the beach both have a line between them and the sun, right? But it's not real. It's just a reflection.
Here's a little combination of both. These clouds are thick and luminous. The sun is underneath. They should be lit according to you, but only the ones that are transparent appear to be lit.
Okay, and the reflection, you know, is different than the shadow. The shadow is something that is actually there and everybody can see it from different angles. A reflection, if you look in the mirror, you may see yourself. If you change your angle, you won't see yourself. You'll see something else. And somebody else at a different angle looking in the mirror will see something else entirely different. So, being that the sun is lower than the clouds from your perspective, that's why it'll appear to light the underside. And that's it. And so there you go. This is awesome proof now for the flat earth, where the sun always stays above the height of the mountains and casts the shadow down, unlike the spinning ball model where the sun would actually go below the clouds and the peak of the mountain. Because this shadow cast, this supposed shadow being cast on the underside of the clouds is not what's happening at all. It's the shadow cast from above the clouds that's darkening the entire cloud. And this is what it looks like from down below. And this is what it looks like from above. So you looking at this picture, you might actually think that the shadow is going up. Well, if you think that, you probably think that the clouds are actually getting higher as they get near you, or that these light poles are actually getting taller as they approach you. But they're not. They're parallel to the ground. Okay, so a real quick way to get these two photos, because how are they the same? I mean, this one's spreading out weird like that from the ground level, and on top it pinches off. Easy way to get this is just look at some train tracks, right? The tracks opening up as they come towards you is the view from underneath the cloud, and the way the railroad tracks pinch in the distance is the view from above the clouds. Okay, so let's go higher. Let's go up to Mount Rainier. And a shout out to a couple commenters who mentioned that the top of Mount Rainier is actually above the cloud layer. So I did some digging, research, and sure enough, yep, it is. So here's a picture from Mount Rainier, and at daybreak, again, you can see the shadow goes down, and it forms a pyramid, a nice perspective pyramid, on the top of the clouds, which is only possible if the sun is above the peak of the mountain, right, Bob? And again, this is daybreak. Okay, and here's another one from the top of Mount Rainier. No clouds present that I can tell. The shadow is being cast on the ground. Daybreak again. Proving, Bob, that the sun has to be higher than the peak of the mountain. And Mount Rainier is over 14,000 feet. And one more thing to point out here is that the top of the mountain that's just above the cloud layer is right where the shadow starts on the mountain. Could this be more evidence, Bob, that the shadow is actually on the top of the clouds? Just like we see here, because the top of the mountain is above the clouds, and that's where it would cast its shadow? And isn't that evidence for the flat Earth, where the sun is always above the mountain, as opposed to your model, where the sun goes down due to the rotation of the Earth and is actually below the mountain? I love that this is something you brought up as a spinning ball model proof, and here I've just turned it around and showed it's really a flat Earth proof. Thank you, Bob. And Bob, I realize your spinning spaceball religion is being destroyed right now. You're triggered, but get a grip, man. Put the hammer down. Bob, you're backing a loser. The ball Earth is over. It's time to get on the P-Brain train, Bob, and head to truth land. Okay, come on. Let's go on. So let's go up even higher. Okay, and here we have Mount Denali, also known as Mount McKinley. Mount Denali. Shadow down on the ground. Again, sorry, Bob, more proof that the sun is higher than the peak of the mountains. And this is daybreak. That's 20,000 feet. Mount Rainier is 14,000 feet. But let's go all the way to the Mac Daddy, Mount Everest, at 30,000 feet. And as you can read here, sunrise on Everest summit. Okay? So, the shadow is clearly down. And what does the sun have to be? Higher than the peak of the mountain? Or why don't you help me out with this one, Bob? Let me borrow a little bit from your opener again. Now, most people that would look at this photo would realize that in order for that mountain to cast that shadow downward onto the tops of the clouds at daybreak, the sun had to be coming from an angle or altitude higher than the peak of the mountain. This is not something that needs to be explained most of the times. It's rather self-evident. Yes, Bob, so this is rather self-evident. And most people would look at this and say that, yeah, the sun has to be higher than the peaks of the mountains to cast shadows downward at the break of dawn or at sunset, right? So you, like I said earlier, you just debunked the spinning ball, because we always see this shadow in the morning and at the end of the day, sunset, from the perspective of the mountain, which proves the sun to be always higher than the peaks of the mountains. And the shadow knows. The shadow doesn't lie. And there you have it, folks. A thorough demolition of the supposed spinning ball proof. A delicious irony indeed, as we turn a spinning ball proof into a flat Earth proof.
That's all easily explained on a globe.
Hello everyone. Today I am going to share a very important video. If you find it as important as I do, then please share it with all of your family and friends. In short, we are going to show with 3D modeling software how sunrises and sunsets prove the Earth is flat. Of course, flat Earth doesn't mean there aren't oceans, mountains, valleys, terrain, etc. The term flat Earth means that there is no Earth curvature, no globe, no ball, and no outer space. In other words, reality. A huge thanks to Paul for making the video you're going to see in a few minutes. Paul was inspired to share the truth, and he has stepped up and spent a long time using his expertise to develop this model without any compensation. Paul is an engineer and computer graphics artist who owns a 3D product animation studio. He contacted me a few months back wanting to do some 3D animations for Flat Earth. Paul and I worked together on this production. If you like his work and want to talk to Paul about 3D product animations or any other 3D content, he specializes in technical product animation. This is Paul's email address for business inquiries. I also want to thank Shadow Reveal, who is an architect who was instrumental in providing advice in making this presentation. According to the official narrative, sunrises and sunsets aren't caused by the sun moving through the sky as it appears daily. Instead, sunsets are supposedly caused by you,
the observer falling backwards at roughly 1,000 miles per hour, while your angle to the sun lowers below your feet and the Earth begins to obstruct the sun until you're entirely in the shadow of the Earth, which results in nighttime. Under the official story, the term sunset is actually a misnomer, because the sun isn't doing anything as you allegedly rotate away from the sun. But for simplicity, we're going to say that the sun is setting, moving, or dropping. And for purposes of this video, we are going to assume an observer roughly at sea level, so that we are talking about the Earth curvature obstructing the sun and not topography. I love this flat Earth evidence because this argument is so simple, and it is dispositive for either side of the globe versus flat Earth discussion. If the globe were real, then the sun must set at an angle lower than the observer's position until the sun drops physically below the observer's feet. That is the simple official narrative. This is the same claim for those few geocentrists who still believe in the globe but claim the Earth is stationary while the local sun and moon rotate around the Earth. On the other hand, flat earthers claim that the sun never sets at an angle lower than your feet. Generally speaking, flat earthers claim the local sun does not physically rise and fall, but simply travels further away from the observer. The sun's apparent setting is caused by perspective and limitation of the sun's light. What's important here is that, according to the flat Earth model, the sun cannot actually travel below the flat Earth and will never be angled below your feet. For those who like logic, this is a classic modus tollens argument. If P, then Q, not Q, therefore not P. If the Earth were a globe, then the sun must set lower than the physical horizon. The sun does not set lower than the physical horizon, therefore the Earth is not a globe. What started all of this was the fact that many globe propagandists have claimed that shadows, like this one of Mount Rainier, are showing an upward shadow of the mountain being cast by a sun that's below the physical horizon. Remember, these globe proponents are claiming the sun is lower than your feet, below the Earth's physical bulge, proving the globe. In fact, what you're seeing here is the top of the mountain casting a shadow on clouds that are physically below the peak. Due to perspective from a lower vantage point, it only appears as though the mountain shadow is angled upwards. Just like these power lines, the power lines aren't growing in size. They're the same size, but perspective makes it look like they're getting bigger. We can say this definitively because there has never been an upward mountain shadow filmed from the apex of a mountain. What's ironic is that this mistaken globe evidence just became the death knell for the globe. You can't have an upward mountain shadow and not have a similar upward Earth bulge shadow causing a similar and noticeable effect. In fact, the globe requires an upward bulge shadow, and that's what we're going to show here today. The first trick of the globe propagandist, like demonstrated by this one, is to show a globe with paper or something else wrapped around it to demonstrate the Earth's shadow and claim that the Earth's shadow could not hit the clouds because the angle is not there. This demonstration is patently deceptive because the paper is wrapped over the clouds. It's the ground that would be creating the Earth's shadow, not the clouds above the Earth. Some globe propagandists will probably claim that the Earth cannot create a distinct visible shadow because the atmosphere supposedly disperses the light of the sun. However, on a clear day, the sun can still create a distinct shadow. Look at this picture of these birds. If a 1-foot-tall bird can cast a distinct and visible shadow, then the bulge of the Earth most certainly would do the same. If small waves can cast a shadow, then the massive Earth bulge would do the same. Now, let's get to Paul's presentation.
Recently, I came across a fascinating set of videos regarding the phenomenon of the apparent shadow casting from Mount Rainier onto some clouds. These videos are from the YouTube channel Taboo Conspiracy. He does some great flat earth videos, so I was eager to hear what his thoughts were on this phenomenon because on its surface, it appears to indicate a globe model. I mean, if the sun can cast a shadow vertically, that would indicate that it is in fact going below the horizon as the globe model claims. In this video, he showed this image. Basically, if the Earth was a globe and the sun was falling over the horizon as the Earth spins, we should see the globe shadow itself shine up on the clouds. This made sense to me, but I really wanted to test it out. So, with my background as an engineer and a CG artist and my familiarity with computer graphics tools, I set out to mock this up with the intention of seeing if this would actually happen. One challenge with 3D programs and space-type projects is scale. Given the supposed distance of the sun being approximately 150 million kilometers or 93 million miles away, and with the Earth with a radius of 6,371 kilometers, or 30,959 miles, these sizes are too great to work with in most typical computer graphics programs. This experiment, the nature of typical CG lighting in a, quote, realistic render package is problematic because they typically have a light intensity fall off baked in. As you get further from the subject, the light intensity has to dramatically increase. At the distances proposed by this globe model, the CG programs really can't adequately represent them. The early days of CG lighting, there was a concept of it's called direct lighting, which basically the light doesn't lose power based upon distance. The light itself also has parallel rays and is supposed to simulate the sun from far distances. Luckily, we can replicate the sun in this experiment with a direct or infinite light. See here the harsh shadows that are cast, and as I move the light away, there is no effect on lighting intensity or the shadow sharpness. What does affect the shadow is the angle of the light. So this will be adequate for this experiment. So I built the model with two known caveats. The model would be scaled and the sun would be a direct light with the infinite parallel rays. Overall, this is not a compromise because the experiment is really to see if the globe/ball would also cast a shadow on the clouds as the sun went down. It's really important to build a replica as much as necessary. These principles are really about angles, line of sight, etc. So the essentials to do this, in my mind, were as follows. A scaled Earth globe, a suitable light source such as direct CGI, a cloud layer, a scaled version of the mountain, and really the approximate location and orientation of this photo, the point of view from which this whole thing took place. So the next question was, where was this photo actually shot from? Looking at the site, you can see Mount Rainier in the background. Another prominent feature was the building just in the foreground. It's next to this small body of water. It turns out that it is the Theus Landing Waterfront Apartments. Also, another noticeable feature was the Tacoma Dome in the middle ground just to the right. And just in front of that was the East 21st Street Bridge. So with all of these locations determined, I could look at a map now to try and approximate this photo location. So looking at Google Maps, we see here the Tacoma Dome. And if you pan a little bit north, you'll see the East 21st Street Bridge. And if you pan a little further north, you'll see this building here that's shaped like an E. It's the Theus Landing Waterfront Apartment. And if you look at the ground photo of the building, it is in fact the exact building. So, if you pan the map up in the line of sight direction, you'll find this building here, which is the Tacoma Sign Company. So while I can't be 100% certain this is where the photo was taken from, it's definitely precise enough for this experiment. So, if you zoom out over the whole entire site, this area is what I needed to replicate and build in 3D. Looking at the overall map of this site, we can get some rough dimensions from the location of the photo to Mount Rainier. The distance away from Mount Rainier is approximately 68.2 kilometers or 42.37 miles. You can also see a Google Map 3D view of the site with the prominent features in the frame. So here's the sphere Earth model scaled 1 kilometer to 1 meter. You can see here the radius is 6,371 meters. As we zoom way down into the model, we'll see Mount Rainier. All of this data for Mount Rainier and Tacoma are from DEM data sources, and they have been scaled to 1 kilometer to 1 meter. Now zooming over to Tacoma, you can see the dome, the East 21st Street Bridge, the Theus Apartments, and now you can start to see the location where the camera was placed in this model. So here I will select the camera that was actually set up to view the scene. And you can see now here is our final shot. For verification purposes, I've placed a couple measurement references in the scene. This first one is the height difference in the model from the photograph to the peak of Mount Rainier. You can see that it is 4.378 meters. Mount Rainier is 4.392 meters above sea level in our model, so our camera is placed approximately 14 meters above sea level. Now we can select on the measurement reference for the distance away. You can see that the length is 68.2 meters or 68.2 kilometers scaled. And this reference is very close to the peak of Mount Rainier. Finally, taking all this information into account, let us compare our scene setup with the actual photo. For this experiment, this is more than adequate to demonstrate the concept of a globe bulge shadow. So here is a final render of the entire site based upon DEM data. The scale is correct and the geometry is correct. The site is ready for our experiment. For our experiment, we will be doing a sunrise. Now let's discuss the concept we're trying to demonstrate. The sun is supposedly located 93 million miles away. This distant sun creates a terminator line from the edges of the sphere. This terminator line or bulge shadow represents where the shadow is cast from. So as the Earth rotates, the terminator stays with the sun. For the demonstration purposes, we're moving the sun in this example. This is what happens from a point of view on the Earth. As we zoom in closer, we see our Mount Rainier location and the terminator line interacting with it. And as we zoom even closer, we can see how the terminator line / bulge shadow interacts with the mountain. Now let's add a cloud layer reference line. Where the bulge shadow crosses the cloud reference line, this is where you might expect to see the bulge shadow on the clouds. So based on these angles, the bulge should show up on the clouds in our experiment. Now we arrive at the scene. It's early morning and the sun is rising in the east. The conditions are perfect to see this rare phenomenon of the mountain casting the shadow on the clouds. Let's see what happens. As you can see, as the sun rotates up, it does in fact interact with the spherical Earth and cast a shadow on the clouds from underneath. Our experiment was set up to mimic the Earth as a sphere, the exact size and conditions for a shadow from Mount Rainier on the clouds, and the hypothesis that as the Earth rotates, the sun goes down below the Earth. If the Earth were a ball, this is what we should see under these special conditions. In fact, if the Earth were a ball, we should probably see this almost every night in some fashion or another. For a closer look at what's going on, let's go back to the schematic. If we pause the sun rotation right here where the shadow crosses the cloud layer just to the west of the mountain, here is the image of what we could expect to see. This experiment is a serious blow to the globe model. After working through this experiment, this is another in a long list of proofs that people can do for themselves. Each one of us can go out each morning at sunrise or each evening at sunset and observe this for ourselves. Do you see this shadow across the sky? For me, I've never experienced this visual in my life on this plane, nor have I seen any photos of this phenomenon to date. What I love most about the flat Earth is that it literally is right in front of us, and it points to our Creator and King. I was always a born-again believer, but flat Earth just adds that much more enjoyment to my appreciation of His creation. Every day when I'm outside, I look at this plane with so much more wonder and amazement, knowing that our Creator is right here, right above us, and we are the center of His eye. I hope you enjoyed this presentation. I'd like to acknowledge Taboo Conspiracy and Shadow Reveal for their very helpful direction and contribution to this experiment and video. God bless.
Using Paul's globe model simulation, this is what sunrise should look like facing Mount Rainier directly eastward. Again, the Earth's bold shadow should precede the mountain shadow. In contrast, this is what a sunset should look like if you were facing west. In summary, during both sunrise and sunset, if we lived on a ball, the Earth itself would cast an upward shadow on the clouds above. For sunrise, the bold shadow would precede the shadow of the mountain or other tall object like this. For sunset, the upward Earth bold shadow would immediately follow the upward shadow of the mountain. If we lived on a ball, we should see some form of the bold shadow twice a day on a nearly daily basis. Without question, this never happens in reality. Therefore, the globe Earth is not reality. If the Earth were a globe, then the sun must set lower than the physical horizon. The sun does not set lower than the physical horizon, therefore, the Earth is not a globe. Thank you for watching.
That's all easily explained on a globe.
That's all easily explained on a globe.
But when we added the atmosphere to the globe model, it did the same thing that it did on the flat Earth model. The apparent sun goes down first, and the real sun follows it. That is contrary to the way refraction is normally presented.
That's going to wrap it up for today.
Ooh, you just got schooled, son.
Put the steps. Wow. I think I just caught that.